Is an accessory to treason. Calm down. Calm down. Yes, go ahead. Stop talking. No, Lord, baby Jesus. What is that, Charles? Is that what Please, can we just go in the room and stop it? This is why I told you he was no good. I'm not against.
Those joining, quickly join and make sure your mic is on mute. Okay, we continue. The question was, please read the question carefully and understand. The question is, why should water really be a gas at room temperature and not a liquid? Simply means it is contrasting with what is already there. They're asking us, why is water liquid instead of gas at room temperature? Okay, so we can raise our hands and answer that question. Are we able to see my screen?
Yeah.
Okay. So, yes, please go ahead.
Water was supposed to be a gas at room temperature because when you look at its composition, it is composed of hydrogen, which is a gas, and hydrogen, which is a gas, and oxygen, which are gases at room temperature and pressure. So the combination of the two should make up something which is a gas.
Okay.
No. No.
Any other attempt? Any other attempt?
I don't agree with that. I really think because it has, let's say, high specific heat of vaporization, that's why it should be liquid.
Any other attempt?
I think it should be gas at room temperature because of its molecular weight. It has a molecular weight of 18.
Why isn't it a gas?
It's not gas because it's not a gas because of the strong covalent bonds between them and the hydrogen bonds, which holds the 2 molecules or more molecules of water together. That's why it's a liquid, not a gas.
So the final answer is what we take, and the others can get this. So starting with the first, it's supposed to be a gas because it has a low molecular weight. H2O should give you a molecular weight less than 16, isn't it? Because carbon dioxide has a molecular weight of what is the weight of carbon dioxide? That's 12 plus the 216. But carbon dioxide, sorry, as a gas is heavier than water as a gas. But you find that carbon dioxide is still a gas, and yet water is the liquid at room temperature. So the first thing is water would have been a gas because of the low molecular weight. Now, what causes this low molecular weight compounds to be liquid is because of the hydrogen bonds. The hydrogen bonds will cause one molecule of water to stick to 4 other water molecules. And those 4 other water molecules, each of those will stick to 4 other water molecules. So you find that these molecules will stick together and will be heavy. Then you have a liquid. Are we getting that?
Yes.
Yeah. It's a concrete point, yeah.
Okay. So because of that hydrogen bonds, we do not have one molecule existing independently. One molecule is bonded to 4 other molecules, and those 4 other molecules are bonded to 4 other molecules just like that. So it does not exist as a single molecule. When it exists as a single molecule, it is in gaseous form after you increase the energy to separate these bonds. So at room temperature, there is not enough energy to separate the bonds. Okay. Why is water a powerful solvent? Anyone? Okay, yeah. Yes, please. Someone has raised their hand, so we'll start with okay. You can go ahead and answer.
Because of its dipolar molecules which expose the partial opposite charges and accommodate both non-ionic as well as ionic molecules or compounds.
Okay, can you please say that again so that everyone can get you? You are very fast.
It's because of its dipolar molecules which expose the partial opposite charges and accommodate both ionic and non-ionic
Okay, so like he said, because water has got partial charges, so it will attract both ionic and non-ionic. So in that sense, these both ionic and non-ionic will dissolve in water. Okay, so we know what adhesion and cohesion are. We already answered this in the brief introduction we had, isn't it? Anyone who has a query on adhesion and cohesion? Okay, I've seen someone raising their hand. Okay, so we move to the next. Explain surface tension. Okay, this one we already did in our lecture, isn't it? In our brief introduction, isn't it?
Yeah.
Okay. Explain the high specific heat of water. Someone to explain this one. Will not manage to skip every question. Let us at least try attempt a few of them. Anyone?
High specific heats of water. It means the energy required to change water from a liquid to gas. Water has a very high specific heat capacity because of the hydrogen bonds. It requires more energy to separate its bonds so that it changes its states from liquid to gas.
Okay, so well read. Okay, the next, explain the heat in the same way. So let's go to 13. In terms of making and breaking bonds, explain why temperature sometimes can change when solids are dissolved in liquids. In terms of making and breaking bonds, explain why temperature sometimes changes when solids are dissolved in liquids. Anyone to attempt this one?
If you dissolve.
Okay, go ahead.
If you dissolve solids in liquids, the bonds between the solids, they break. So breaking of bonds, it releases energy, so to say, lack of a better term. And if it releases energy, it causes to raise the temperature of the liquid, because when bonds are broken, heat or energy is released, therefore raising the temperature. But if bonds are made, then energy is consumed or heat is consumed, so to say.
Okay, so when you look at your exothermic and endothermic reactions, remember some bond breaking causes release of energy, and some bond breaking again absorbs energy. So it depends with the type of reaction we are talking about. Okay, otherwise that is it in summary. There is energy released and energy absorbed. Okay. The next question: how can you predict which solids and liquids and gases will dissolve in water? Anyone? Question 14.
I think all ionic compounds or all ionic liquids, solids, and gases can dissolve in water. Or may simply say any substance which has a charge can dissolve.
Sorry, I couldn't get you. Are you able to, the rest of you able to get me? I think we lost your audio. Okay. Are you able to get me?
Yes, yes.
Yes.
Yes, you can repeat your answer. You are getting somewhere.
I was saying that all ionic compounds can dissolve in water. In simple terms, any compound molecule which has got a charge can dissolve in water.
Okay. So as long as that element, that solid, that liquid, that gas has a charge, it will dissolve in water. That is the best answer you can give. Thank you for that. So we mix alcohol, oil, corn syrup into water. So to see which of these will dissolve in water, the alcohol and the corn syrup will dissolve, but the oil did not dissolve. So at molecular level, why did the oil not dissolve in water? That's a similar answer to the previous question.
Because it's not an ionic substance.
Not really only
Because it
ionic.
has no polarity.
Yes, the bonds in
Non-polar.
oil, the molecules in oil are made of carbon and hydrogen bonds. Now, carbon and hydrogen bonds does not make it polar. It has no charge. There's no polarity on there, or there's no charge on the oil. So the oil will be repelled instead. The other things will be attracted and they'll be separated. Okay, so there's no charge on the oil. Why does increasing the temperature cause more solids to dissolve in a solvent? Yes? Why does increasing the temperature cause more solids to dissolve in the solvent? Yes, please, you can go ahead and answer.
Can you?
Go
Okay,
ahead.
it's because because
We can
an
talk about
increase in
increase.
temperature.
Okay, one at a time.
Go
Okay,
ahead,
the
my brother.
increase in temperature will increase the collision of particles there. So increase in collision of particles enables it to dissolve faster. That's one way I can put it.
Okay, the other one, you can give us your contribution.
Yeah, similarly, an increase in temperature increases the average kinetic of like the average kinetic of the movements of molecules rather.
Okay, so once you increase the movement of molecules, just to add on, it simply means you increase the rate at which the water molecules attract the substance you're dissolving, the solute. So once you increase that rate, it will cause the splitting or the dissolving to be faster. Remember, what causes dissolving is the attraction of water molecules to what you've put in the water. If what you've put in the water does not have a charge, it will not be attracted by the water molecules. So it will not dissolve even at high temperature. Okay? So when you increase the temperature, increase the rate at which the interactions with the charges of water takes place. Okay, we move. So why, okay, this is a similar question. Why does sugar not dissolve in mineral oil? We answered it earlier. So sodium chloride is made of sodium and chlorine. So using your knowledge on polarity, explain why water is able to dissolve salt. So this one we've already answered. Okay. And these questions we've already been talking about them. So this was basically our session for today. Please feel free to join again the next time we have this session. Okay, and Is there any questions?
Sir.
for today? Yes, sir.
Sir, is it possible for you to lecture on like proteins?
Okay, so you can forward your requests through the person who's organizing the meeting.
All right, or in the group. How do you?
In that group. So you forward your request through him, then it will come back to me. So whatever you need to communicate, request, you can forward it through them.
All right, thank you.
Thank you.
Sir, kindly go back to the first page of the questions.
This one. Yes, madam. I would have shared more questions with you, but we don't have time to share all the questions. Yeah, just that. So we still have, I think, 7 minutes, 6 minutes. Maybe we can look at a few MCQs if everyone is okay with that.
Sure, we can. And I think I've sent you a direct message. I don't know if you've seen it.
Okay. All right. Let's try to.
Sir, has a question. I think. Oh, I'm asking if you can explain a bit on the structure, the first part of the presentation. I came in quite late.
Okay. For your case, we'll go to the first slide. Okay. So this is the structure of the water molecule. The water molecule has got an oxygen atom bonded or bound to 2 hydrogen atoms. Okay. Now, if you look at the electron configuration of oxygen, it is 2, 6, isn't it? Because oxygen has got 8 electrons, isn't it? So those 6 electrons outside needed to be 8 in order for it to be complete and to be stable. So now those remaining 2 electrons will come from the hydrogen atoms. Now hydrogen in its bond only has 1 electron and 1 proton. Now because of that 1 electron and 1 proton, hydrogen also needs another electron in its outer shell to complete the bond. So in order for that to happen, the hydrogen will share its electron with the other electron from the oxygen to have 2 electrons on the outermost. Now, because the hydrogen only has 1 proton and 1 electron, that electron will go towards the oxygen side and the proton will remain on the opposite side. Because of that, you're going to have a slight positive charge here, which you see here. Okay? And since the oxygen had gained that electron from the hydrogen, it's going to have a slight negative charge, which you see here. Okay? So the same happens to this other hydrogen. Therefore, oxygen is dipolar. It has 2 poles. The positive 4 on the hydrogen sides and the negative 4 on the oxygen side. Sorry for that. It keeps the problem with my inputs. Okay. So because of that, you're going to have a slight negative charge on the oxygen side. There will be 2, and slight negative charge, positive charge on the hydrogens. Now, okay. Now, because of that, or because of that that attraction, you have the charge on the oxygen, on the water molecule. Now, these 2 positives and negatives don't cancel each other because of the nature of the bonds. Okay, the space in between the bonds, or the moments, look at moments and so on, you find that there's a resultant. It does not fall in the same line or at the same position because of the angle between the oxygen and hydrogen. Okay, is that question answered?
Oh, yeah, it is.
Okay,
Yes.
thank you. Any more questions? Okay, so that wraps up our meeting. So we'll meet again in the next session. Okay.
All right, sir. Thank you.
All right, you're welcome.
Mami, simuenda.
Niende kuti.
Yeah.
Unapaswa waenda mpaka
Vibe.
Let's join another meeting. Is
Agba?
there another meeting at 19?
upeze waenda kanchonza kwa wasara wapunzira. First waende watiuta ndepeti yenda. Eventually